So today I will be presenting to you the standards lesson for 6 through 12 math, and our focus is math patterns and relationships, and this is Catherine Bryan talking. So this is our lesson plan over here to the left. We're really outlining number patterns, and that's like an extension from our K6 or K5 lesson plan. So we're assuming that the child knows algebra, exponents, multiplication tables by memory, geometry, shapes, area, perimeter, and number patterns, has like a basic understanding. Our goal grades is like 9th through 10th grade. And our objective is to aid Matheson in discovering how to solve a word problem involving both number patterns and algebra. Um, so here's just a basic summary of our lesson. You can feel free to read it to the full extent later. And this is our source. We basically modified the question to fit this example a little bit better. So here on the Smart Notebook, this is a worksheet that we'll give the students. So it's called Matheson's Milk Crate Conundrum. So Matheson has a problem. He works with a company that uses square-bottomed milk crates. These can be divided up to contain a square number of bottles fitting the crates with dividers. Using two dividers, Matheson can fit 4 bottles into the crate. So 2 dividers can fit 4 bottles, which is illustrated here. And then using 4 dividers, he can fit 9 bottles into another crate. Both of these situations are shown in this illustration. So here are the 2 objective questions that we're going to focus on. On Friday, Matheson's boss wants to know how many bottles he can fit into a square crate if 30 dividers are used. So we're going to focus on that one first. So here's the question again. So we're going to encourage our students to use a table, a two-way table. So number of dividers is your X component and number of milk bottles is your Y. So just start with basics. We have 2 dividers and 4 bottles can fit in it. And then 4 dividers and 9. Those are both illustrated in the pictures. They can ignore these exponents. We'll get back to those later. So we just kept going up on this side by multiples of 2. So 6 dividers, 16. So it just continues. You begin to see a pattern until you reach the 30 dividers. But we're going to stress that our children develop like an algebraic expression. So just to keep moving for the sake of time, we're going to show them that this is a pattern over here, like this increases by 2, by 2, by 2, all the way up to 30. And then those are your x values, and then your y values will also increase by x squared. So it goes from like 2x squared, 3x squared, 4x squared, 5x squared, etc., etc. So then you'll have a difference of x squared, which will also ultimately have a difference of 1. So that's like how we're going to try to brainstorm. We wouldn't just give them the table. We'd have like, going back to the lesson, we'd have directive questions and such, but just for the sake of time, we're kind of moving quickly. So then that brings us to the second problem, which is the 100 milk bottles problem. So since 100, we're going to take this one a little bit different. Since the question is, on Tuesday, Matheson's boss wants to know how many dividers would be needed for a square crate that could hold 100 milk bottles. So this is how we're going to walk through that just quickly. Since 100 is 10 squared, since 10 is a square number, and 10 minus 1 is 9, then 2 times 9 is the number of dividers that need to be used. Because we know based on this table that if we find the perfect square, 1 less is going to be what we need times 2. So then, which brings us to our next day warm-up problem, which just is a continuation of the lesson. So we're really trying to stress the importance of number patterns and how these patterns will lead us to they'll lead us to one specific they'll lead us to one specific equation based on the pattern. So the equation will end up being like the square root of whatever you get for this. So it'd be 10 squared, and then 10 minus 1, your x minus 1 is 9 in this case. So then 2 times what your answer is here will give you how many dividers you need. And then it would just like vary based on the problem. So I want to thank you for listening to our lesson, and I have a good day.